Next, I want to look at a third kind of transformation, and this is when we have stretching and shrinking, or you can also call shrinking and compressing. So this is your third one. And again, these are the three that we're focusing on. There are other kinds of transformations too, but we're going to focus on these three main ones. And what you notice for stretching and shrinking is that the change is going to be some sort of multiplication or division. And the graph is either going to get pulled long, or maybe it'll get compressed together, or it could get pulled wide or compressed together. So the shape is still going to stay the same, but in this case, you actually do have some sort of pulling or compressing, whereas in the other examples we've done, the shape has stayed perfectly the same. Here it's going to get tweaked a little bit, but you'll have the same kind of curve. So if it was a U-shaped curve, it's still going to be U-shaped. It just may be a little bit longer or wider or something like that. Again, there's vertical and horizontal changes. So for the first case here, we're multiplying on the outside. So if you're multiplying the outside function by a value, this is some sort of vertical change. So if your C is greater than 1, you end up stretching it. And if your C is less than 1, so like a fraction, you end up compressing it. These ones I think are a little bit harder to just visually do. It's hard to figure out, well, how much do I stretch by? How much do I compress by? So I do recommend using a table here. And the way you can find your table is by multiplying the Y values in your original graph by C. If you have the C being multiplied on the inside, then you have some sort of horizontal change. And again, remember, it works opposite. So if C is big here, you actually are shrinking it and compressing it. And if C is small, it's actually getting wider. So it's the opposite of what you would think. Again, I think it's really hard to just kind of visually do. So I usually use a table here to help me. And you can find the table by taking your points and dividing the X values in the original graph by C. So again, notice the change. We're not multiplying, we're dividing the X values. So it's an opposite idea of what you would think. So let's look at a couple of examples here. So here is my parent function. We haven't seen this one yet, so we'll do out a table here. And then here is my transform function. If I go back to my first page, my cubic function looks like this. So I can see it's going to be something like this, but I am going to find a few points here. I haven't done this one yet. So I'm going to pick points on both sides. And then I'm going to apply the cubic. So -2 cubed is -8. -1 cubed is -1. 0 cubed is 0. 1 cubed is 1. And 2 cubed is 8, right? 2 times 2 times 2. Okay. And then my graph looks something like this. No, it's not perfect, but you guys get the idea. Okay. Now, my transform graph is very, very similar, but I have this one change here. Notice that we are multiplying on the outside by 1/2. And again, how do you know it's outside? If it was inside, it would clearly be inside something. You would see parentheses, you would see a root, you would see the absolute value, or a denominator. That's usually the other one we sometimes see. But you would see something that's clearly showing inside. If there's nothing there, this is just being multiplied outside of the function. So we have an outside change here. So our outside change is going to be a vertical change. And what we do is we multiply the Y values by whatever that number is. So I'm going to multiply my Y's by that 1/2. Okay, so your X values stay the same. And all those Y's, I'm going to multiply by 1/2. So for the first one, you have 1/2 times -8, which is -4. 1/2 times -1, well, that's just -1/2. 1/2 times 0 is 0. 1/2 times 1 is 1/2. And then, okay, and then 1/2, sorry, times 8 is going to be 4. Just want to make sure I'm reading my right values there. So let's go ahead and plot this. The 0, 0 still stays. On the 1, we're at 1/2 though. And on the negative 1, we're at -1/2. I'm just going to do my best there. And then at 2, I'm only at 4. 1, 2, 3, 4. And then here at -2, I'm at -1, 2, 3, 4. So it's a little hard to see, but you're actually kind of getting a bit of a compression here, right? It's not stretching as quickly, it's stretching slower because we're only going up to 4 instead of 8 for that x equals 2 value, for instance. So again, a little hard to see, but we're getting a little compression there. And let's do another one. So this one's a different style. This one, we're not starting with a parent function that we're familiar with. Your book is actually giving you a different function to use. So I want to do one of those as well. So I'm just going to recreate it from your book. I think it's easier to do that. So I have the point -4, 0, and then -2, 4. So this is -2, 4, and then -4, 0. The point 0, 0. To -2, and then 4, 0. And what your graph looks like is this. It's a curve on this side, like a little U. And then it's a V on this side. Okay. So I'm just going to make a little table here. So this is the original function. This is your f of x function. And again, this is given to you. So the book is telling you use this as your parent function here. So I have -4, 0, -2, 4, 0, 0, 2, -2, and then, sorry, that was 4, 0. Okay. So that's my starting function. And then I'm going to do A and B. And I just have 2 different graphs here. So I'm going to do one on each graph. So this is going to be A, where we're looking at g of x equals f of 2x. And then this graph will be B, where we use h of x equals f of 1/2 x. Now, notice that both of these changes are inside changes, right? So if you look at the definition, right, it's inside the parentheses, and I have an inside 2 here, and I have an inside 1/2 here. So both of these are inside changes. And if you look at the notes, you can see that when you have an inside change, what you're going to do is divide your x values on the original graph. So for the first one, we're going to divide our x's by 2. And then here we're going to divide our x's by 1/2. Right, so that's the change. Inside changes, you're working with the x's because it's a horizontal change. So let's do these each out. So I'm just going to do some work right here. I think it'll be easier. Notice that in both cases, my y's are staying the same. So I'm not touching the y's. I'm just touching the x's. So for A, I'm dividing my x's by 2. So -4 divided by 2 is -2, right? So -4 divided by 2 is -2. -2 divided by 2 is -1. 0 divided by 2 is still 0. 2 divided by 2 is 1. And then 4 divided by 2 is 2. So I'm going to have the same shape, but this is going to be my new x value. So let's see what happens with the graph there. All right, so I have -2, 0, -1, 4, 0, 0, 1, -2, and 2, 0. But you have to keep the same shape. So it's going to be a little U on the left and then like a V on the right. So that's my new graph. So you can see that having that 2 is compressing us horizontally. So it's making the graph kind of squish in together. Let's do B as well. So I'll do my table for B down here. I guess I should use g of x here, right? We're using g of x. And then this one, we're using h of x. So my y values are staying the same still. Okay. And now this time I need to divide my x's by 1/2. So let's be a little careful there. I'm going to do some workout. I'll do my work in between here. So I have -2 divided by 1/2. Well, when we divide by a fraction, we actually change it to multiplication. And don't forget, we flip this. So I'm actually going to multiply by 2/1, which is just 2. So -2 times 2 is -4. Oh, hang on, guys. Oh, my goodness. Pause for a second. I was using the wrong table. When you are doing a new problem, so again, we're not continuing on here. I should have paid more attention myself. We're using the original function, the f, not the one that we just did. So excuse me, I have to go back to this table here. So it's -4 divided by 1/2, which is -4 times 2, which is -8. So this first value should be -8. All right, let's do the next one. I'm going to make sure I use the right table here. So -2 divided by 1/2 is going to be -2 times 2/1, which is -4. Now 0 divided by 1/2 is 0 times 2/1, which is just 0. And then I have 2 divided by 1/2 is 2 times 2/1, which is 4. And then finally, the last one is 4 here. So 4 divided by 1/2 is 4 times 2/1, which is 8. So let me plot these. I have -8, so 5, 6, 7, 8, 0. -4, 4, 0, 0. 4, -2, and 5, 6, 7, 8, 0. Now I'm going to keep the same shape, so curved on the left, and then a V shape on the right. And again, we're comparing to the original function. So I make mistakes too. Be careful there. I wasn't paying attention. I was using the wrong table. So here, our original function comparing to that f function. So you can see starting with the original function compared to the new one, now we have that stretching. So we're kind of pulling that function horizontally. So those are the last transformations we're going to do. There's also rotations and things like that. We're not going to worry about that if you've seen those before. And I think personally, the stretching and the shrinking is the hardest one. For me, I have to use a table. I can't visually do it. I can kind of mentally figure out if it's going vertical or horizontal, like I can figure that out, but to find the exact points, I have to write it out. So for me, I usually make a table, do out the work, and then use that to help me. Now, we've been doing most of our examples with just a single transformation, or we had one in the last video that had 2 transformations, 2 shifts, but we actually can put this all together. So you can have more than one transformation applied to a parent function. And when you do that, you basically just want to follow the order of operations. So work inside the parentheses to outside, and then obviously performing multiplication before you perform addition at the end. So if you just remember the order of operations, then you should be fine. And if you forget that though, this is the general order that you're going to follow. So you're going to do horizontal shifting first, because that would be inside parentheses. Then you would do stretching or shrinking, which is a multiplication or division piece. Then you can do your reflecting, which is a multiplying by a negative. For me, I often do these in the same step because usually they're together. So you can usually combine that step. And then the very last thing should always be vertical shifting. And that's actually really important. If you have multiple kinds of operations that are not just shifts, like if they're mixed operations, like you have reflections and you have shifts, or you have stretching and shrinking and you have shifts, then that vertical shifting has to come last. Otherwise, it does mess up the whole process. So that's the big one. If you can remember that comes last, then you'll probably be okay with the rest of them. But just remember inside to outside. So your vertical shifting is going to be the absolute last thing that you're going to do. It's an outside change, and it's also addition and subtraction, which comes at the very end of the order of operations. So that's your last step. All right, in the next video, we're going to do 2 examples out that use multiple transformations, so you can see how those work.